All right, so we're going to take a look at a few more problems here. I'm just going to get you started. We're going to look at number 23, and then you'll do 24 and answer some of these conceptual questions. All right, so number 23, we're going to do a reflection over the y-axis followed by a translation. So that is a composition of reflections, or sorry, composition of transformations. It's not two reflections, but it doesn't have to be. So we're gonna go over the y-axis, which is this guy, and then after that we're going to do a translation 3 units up. Okay, let's start with the y reflection. So this guy stays in the same place. This guy is 1, 2, 3 away from the line of reflection, so its image is 1, 2, 3 away. This one's 1, 2, 3 away, so its image is 1, 2, 3 away. And this guy's on the mirror, so its image is on the mirror. Connect our lines here. All right, there we go. Okay, so that's the first one. Now the next one is we translate 3 units up. So everybody moves up 3. So this guy, 1, 2, 3. And this guy, 1, 2, 3. And this guy, 1, 2, 3. Here's our new one. So again, we want to see that middle step here. But this guy's our final. And since it's our final, maybe this is a good idea. You can go in and shade your final so that I know this is the ending point. So pre-image to image, then this becomes the pre-image and this is the final image. Cool. All right. This is what you call, you can call this a glide reflection. So if you translate and reflect, or reflect and then translate, it's called a glide reflection. But one thing to keep in mind that's really, really important, a really big conceptual idea, is that when we do a rigid motion, which is any translation, reflection, rotation, or any combination or composition of those three, it's called a rigid motion, we get a congruent shape, a congruent figure. This triangle and this triangle are congruent to each other. None of the angles of the triangle changed. None of the side lengths changed. Everything's preserved. It's just in a different orientation. So if you can map one shape to another shape using a rigid motion, you know those two shapes are congruent because you didn't change any of the angles or you didn't change any of the segment measurements, or the side measurements. Okay, so that's important concepts about rigid motions and congruent figures. Okay, so you're going to do 24. You can do it. So you're going to translate first, and then you're going to reflect. Okay, this one has a rule, so you're going to have to remember what that means. And then you're going to reflect over the x-axis. And then you got these questions here, which if you were kind of listening to that explanation I just did in 23, then these should be pretty easy to get. And if you're not sure, then you can go to these pages in your book, and they're like the key concepts. They're like bold or highlighted or both. So look for the bold keywords because those are important ideas. And then we also talked about this just a minute ago. So these are conceptual questions. I want to make sure you know what the answers to those are on your own, but that will kind of help you get through this assignment. And if you've been following along, cool, you're awesome. You're like almost halfway done, and you probably could have done it on the way. So I'm hoping that with all those videos, although there's a lot that will get you through there, maybe you didn't need them, maybe you did, but I'm kind of erring on the side of too much information these days. So hope that helps, and I hope you guys are doing great and staying healthy and staying sane, and I'll see you guys on the next video.